Good afternoon, everyone. So before getting started, I would like to offer a land acknowledgement because we are speaking today on Lenape, and my research takes place on Lenape, which is the ancestral and spiritual homeland of the Lenape people. So my talk is entitled Lenape Agriculture in the Minisink, but first I want to talk about modern agriculture. So in the United States, our agricultural systems are what we call a monocropping type system, which means that acres of fields are planted with just one type of crop, usually one that requires a lot of nutrients for its production. And because of these systems, we have a highly mechanized agricultural system, meaning we need heavy machinery to harvest and plant these crops. And we also rely a lot on chemical fertilizers and herbicides and pesticides to allow for the success of these crops. What this means is that these systems are highly unsustainable. They release about 657.9 million tons of CO2 into the atmosphere every year, which makes up 11% of the entire greenhouse gas emissions in the United States. And that's not even counting for the transportation of these goods and the production of these chemical fertilizers. As such, a lot of legislation and policy has been focused on how we can make these agricultural systems more sustainable. One idea proposed by a lot of agroecologists is that we need to return to indigenous agricultural systems. So indigenous agricultural systems are systems that were used by the indigenous people of a region before Western science, Western technologies were implemented in these regions. And the reason why they emphasize that we need to return to these systems is they're actually a lot more sustainable and actually even more productive. They were developed over hundreds, if not thousands of years to maximize production within these areas. They're less extractive of the land. They improve biodiversity. We actually have some real-world examples of where these indigenous agricultural systems have shown that they are more productive and more sustainable. So the first is from Bali, where the agricultural rice systems that have been in place for hundreds, if not thousands of years were put back into place after the failures of the Green Revolution in that area. And then in Peru, Penn archaeologist Clark Erickson, who's now retired, did some experiments in the 1980s with these raised field systems that were in place thousands of years ago and found that they were so widely productive that it expanded from one community to 40 communities, and the Peruvian government eventually took it over. But the problem is a lot of these systems have been lost thanks to the violence of colonialism. And that's where archaeology can come in. So archaeologists love to talk about agriculture. It marks a big transition in human society, and I think archaeologists just like talking about food. It's something we all need to survive on a daily basis. And there's three main ways that we can study past agricultural systems. The first is these actual agricultural landscapes that get left behind in some places. For example, these field systems from the Southwest. We can also study the agricultural tools that people were using. So things like stone and bone hoes, axes to cut down trees. And then we can also study the plant remains that people left behind, and that's actually what I'm going to focus on today. So my research takes place in the Minisink region. So if we're down here, wrong button. If we're down here in Philadelphia, the Minisink region is about 2 to 2.5, 3 hours north of here in what's now the Delaware Water Gap National Recreation Area. So it spans from the Delaware Water Gap up to where New Jersey, Pennsylvania, and New York all meet along the Delaware River. More specifically, I work in what's known as the Minisink National Historic Landmark. It's about a 1,320-acre site that was occupied by the Lenape from about 3,000 years ago to about 1,700 when they were forcibly removed from the land. So the period I work in is called the Woodland period. It spans from about 800 BC to that 1700, 1675 period when the Lenape were taken from the land. Maize was first introduced, so the Lenape were maize agriculturalists. They subsisted primarily on maize. It was first introduced sometime during this early Woodland period, about 800 to BC to 0 AD. But it didn't become really visible and probably wasn't planted in the region until about 600 AD, which is when we first start seeing it in the archaeological record. But it's not super common in the archaeological record from this period. We don't think they were really growing a lot of maize. But then you see this giant spike of maize in about 1300, and it remains fairly consistent. It declines a little, but that's more related to sample size and things like that. So why does it spike around 1300? There's a number of reasons why, climate change, introduction of different technologies, but one of the main reasons is actually the introduction of the bean. So the bean first becomes visible in the archaeological record around 1300. And beans are really important for two reasons. One is they provide actually complementary amino acids with maize that allow for you to have no nutrient deficiencies when you're eating maize and corn for the majority of your food. The second reason is beans are a legume, which means they're a nitrogen-fixing plant. As a nitrogen-fixing plant, they add nitrogen back into the soil, which is really important for corn because it takes a lot of nitrogen out of the soil, which is a major issue with modern agriculture and why we have to fertilize so much. So the introduction of beans allowed for the development of the Three Sisters agricultural system, which was the co-planting of maize, beans, and squash. The maize provided, your main source of food, but also a stalk for the bean to grow up, and the squash provided ground cover, which actually eliminated the need for irrigation because it trapped moisture in the soil. This is typically how we think of northeastern indigenous agricultural systems. But they're actually a little more diverse than this. So in my research, I have found the Lenape weren't just planting maize, beans, and squash in their fields, but other crops. So we have chenopodium, or lamb's quarters. It's considered a weed today. If you're a gardener, you might be picking it out of your garden. But in actuality, it's like a North American version of quinoa, so a high-protein plant. They also would have had sunflowers in these fields, and I also included a picture of tobacco. This was probably gardened elsewhere near houses, but it's just a pretty seed, so I like including that picture. But beyond just these other crops they were planting, maize agriculture actually increased the diversity of plants available to the Lenape, most likely through these disturbance-adjusted plants that were growing around the maize fields. So we can see before maize was introduced, the diversity of plants that they were utilizing was actually pretty low. As maize gets introduced, it goes up some, but then really when maize use was at its highest, we see the highest amount of diversity. And this is because the disturbance-adapted environments of an agricultural field allowed for the growth of things like blueberries, raspberries, sumac, huckleberries, blackberries, all types of different fruits and seeds that would have added extra nutrition to the diet. So we actually see the quantities of these plants and the amount of plants increasing, and it's probably because they were attracted to these field environments that were heavily disturbed. So going back to a modern maize field, if we look at a maize field today, you can see that it's just corn as far as the eye can see. There's no diversity here. To get this, you have to use heavy machinery to till the land, to plant the seeds, to harvest it, adding pollutants into the air. There's no other plants growing around, so it's really not a diverse system. It's hindering biodiversity. We see some weeds down here, but it's not really much. So if we compare that to the Lenape agricultural system, we'd improve biodiversity, improve the sustainability of these methods, because you can't farm this way using mechanical methods. You don't actually need fertilizers, you don't need pesticides, you don't need herbicides. So if we can re-implement these agricultural systems in the Minisink region, in the Delaware Valley, and also study them throughout the entire United States, we can improve our agricultural sustainability today. Thank you.